we will be going through a lot of the sort of the getting started level of content, and so this is content that uh, you several teams across the facility pulled together and really trying to touch on the getting started aspects of using a machine like Aurora, and so we will in many cases refrain from doing a deep dive into a lot of topics. And really, it's not that we don't want to discuss it. It's just that we want to try to get through all of this high level content. The deep dive discussion can certainly happen in the Zoom chat and for those who have access to Slack chat. And so, you know, any question is certainly appropriate and valid. And so I encourage you to ask. Um, and so with that, I mean the flow of today will very much be relying on material in. How do I stop this thing from blinking every time? Um,
What is blinking?
Maybe only I see the Zoom thing blinking back and forth. Sorry. So we will very much be going through content that's in this GitHub repo. And so as you said, I think everyone had it's been provided, but github.com, Argonne-LCF, ALCF beginner's guide, and we're sitting in the Aurora directory for that. Um, and so really, you know, I think most folks understand what Aurora is. It's, one of the US's first exascale systems in the world. So it's a very powerful resource, very much geared towards not only traditional modeling and simulation, but also AI and data intensive workloads. And so with that comes a variety of potential workloads that we need to support. And so we'll be touching on all of those today. Um, for those who have come on site to the lab, one of the nice things that we have is a really nice viewing area. And so if, anytime someone's on site, I encourage folks to go and check it out and take a look at the full machine. Um, you can see pictures of the compute racks where all of the science happens. I think these are closed off now, but you could, when they're open, you can see, look at it. This is a liquid cooled system. And so you can see even the mechanics of trying to keep this system up and running. Um, at a high level, again, this is a machine that has achieved an exaflop worth of performance in double precision with the HPL benchmark. And so this is when folks look at when they see announcements of the top 500 list, this is the benchmark that's being discussed. Other benchmarks as well, particularly noteworthy is this mixed precision AI benchmark. And so they're in excess of 10 exaflops of performance. So this is truly a performance system. Um, it is a large system, more than 10,000 nodes across the full system, a lot of memory. And this is really, one of those important aspects for any of those applications that need lots of memory capacity. This is one of the reasons why an Aurora would be a good fit for those workloads. There's almost parity between the available CPU memory from a DDR perspective with the HPM memory on the GPUs. And we additionally, on the CPU side, have an additional, petabyte or so of HBM memory. Um, Kind of getting down into some of the details. And again, I'll try to stay high level, and so I'm gonna gloss over some things, but questions in the Zoom chat are more than welcome. Each node in Aurora, six Intel GPUs. The two Intel CPUs. The CPUs very much are continuing on in the Xeon line, with the addition of now having HBM memory attached to it. Uh, and then one thing I want to impress, and then I'll say more later when talking about some of the later topics, is there's a lot of CPU resources here, and so I think it's very encouraging and important to realize that there's a potential for a lot of performance by utilizing all of the CPU resources available. Um, and on each node is a misspelling word that I see here, but also 8 slingshot network points. And so each compute node, really a lot of GPU resources, a lot of CPU resources, and a lot of networking, and really a lot of powerful resources in a very dense form factor. The image below, and this is one that you may want to click on and zoom in on your own screens. Uh, at a high level, and again, I won't go down too far into the weeds, but the GPUs, the six GPUs on the node have an all-to-all connectivity. So, passing data back and forth between the GPUs doesn't need to go through a CPU, for example. The GPUs you can divide them in halves, and so the top three GPUs are connected to the CPU that's on the top. These three GPUs on the bottom are connected to the CPU down here. And so there's a fast connection between this CPU and this grouping of GPUs. And so that's one of those topics that or a detail that will be mindful when thinking about performance is binding CPU tasks to the right GPU to minimize cost of moving data back and forth. The CPUs have a fast connection between them. The CPUs are connected to a PCI switch, and then that's how they get out to the four NICs. And so, in some sense, you can kind of divide the node in half, and try to think about how to leverage resources in that manner. Um, and again, yeah, a lot of memory on the CPU side, both traditional DDR and HBM. Um, this kind of spells out a little more detail, and I'll only touch on it a little bit here, and this will be more um, focused in later discussions. That when thinking about how to map your applications to the nodes, it isn't, in day one, it's okay to kind of gloss over some of these details, but it is good to start thinking about it. Again, a lot of CPU resources and a lot of GPU resources. And in this coding scheme is that one potential way to think about it would be to have 8 CPU cores for an individual MPI rank, for example, or maybe 8 MPI ranks, and all of them targeting a part of a GPU. And so that's what this color coding is trying to get across, is that thinking about how to map software processes, MPI or OpenMP, on the CPU, mapping them to the GPU. And again, I just mentioned this kind of to get people to start thinking about it and how they might map their application based on experience with other machines. And then this will be very much we'll go into more detail later on. And so, you know, that high level intro, and you can see sort of the topics that we'll run through here on the side. But first and foremost, getting started on the machine, how do we access it? Well, we SSH into the machine, and so hopefully everyone has already established a connection there. Um, so I'm already connected to the system, and so when I type, SSH my username at aurora.alcf.ano.gov, I get connected. And so if I wasn't already connected, I would get prompted for my mobile pass token. As what you see in the screenshot, you'd have the password prompt there, and then you'd go to your mobile pass app, enter your PIN, get back the passcode, and then put that into the shell to get access to it. Um, and so here, when the shell, when you land, we're sitting on a user access node, the login node for the Aurora system. Uh, if you do list, oh, that's horrible. But you'd see the contents of your home directory, print working directory, home night. So night's my username. Uh, this home directory here on Aurora is separate from the home directory that you'd find on some of the other ALCF systems like Polaris. And so that's an important thing to note for the how the system is set up today. This is something that will change in the near future. And so, while today we have separate homes, for example, for Polaris and for Aurora, sometime in the near future we'll merge and have a single home that's accessible by all the systems. Uh, Similarly, the project space, and this is where a lot of all of the science should be happening. The project space is set up for more performance I/O. And so the project spaces are all located in Luster Flare projects. And so if, for example, you were coming from Polaris, you might be familiar with the Grand and the Eagle project spaces. On Aurora, we have the Flare project space. Um, and so one of the first things that we'll do is again, all of this work is available in a GitHub repo. And so we can go down to the ALCF training space that's available for everyone that's registered in this workshop. We can create a directory there. We can clone the repo, and we can do all of our work in that shared space. And so if I change down into Luster, Flare, projects, ALCF training, if I list the contents, I can see a handful of people have already started doing the work down there. And so, if you're going to use this space, very much encouraged to place files in your own directory. And so I'll make a night directory for myself. Uh, and I apologize the way that the prompt is cutting everything off. So hopefully folks can follow along at least in the Git. Um, and so really, and I will really be copy and pasting commands for the most part. And so, we can clone the repo.
Chris, if you want, you can decrease the size of your screen so it fits better the shell.
I don't think it's going to help much.
Okay.
And so again, that copy pasting from the repo, you git clone, and then the path to the ALCF Beginner's Guide repository. And then change into there. And so there, I mean, really, you'll see everything, all of the content that we're looking at on the right side of the screen, and along with several examples. Um, One of the nice things that we currently have with the Aurora, the way that it's set up is the modules that you might load to say, load a compiler or load a library or tools. Those are available by default. And so most folks to get started will not need to load a module. Um, so you can, run module list and you can see what's currently available in the default environment. And so a lot of the important bits from the Intel software stack are already available. Um, if you want to see what else is available, maybe there's a library that you want to load, module avail will show you what's all of there. Um, IO libraries like Adios, frameworks, Kibana, some software for the CPU is available. PETC is available for anyone that may need that. So there is a number of things here that's already available for users that, dependencies for building your applications that you might find useful. Um, uh, Additionally, we have this is one set of software that's available. There's also additional software that the ALCF staff provides, and that's in a different module path. And so if we go through all of this content that's available, all right, we can add another module path. So module use slash soft module files. And then this will load an additional set. And so as you can see in the screenshot on the right, we have a handful of things here like Jax, and Tau, and Chipstar. So then if you run module avail again, you'll see these additional ones included, soft module files in here. And so there are things available. And so, if you see, hopefully you can find what you need. If not, that's a good opportunity for interacting with the support at ALCF. And so you can send us a ticket to inquire about the software. Or if you run into issues building the software dependency, I mean, these are very good questions to ask. Um, with that, it won't let me. Um, most folks, CMake is a module that you might want to load to build your applications. And so module load CMake is sufficient to bring that into the environment. Uh, and additionally, there's also through the soft module files that are pieces of software installed via SPAC. And so that's another place where you may find a lot of the components that help you with building your applications. Um, so this, super high level intro into just getting onto the system and navigating it.